All right, this is the second lesson in Unit 7. The lesson is called Parallelograms. Okay, Parallelograms. So you probably know what this definition is based on the lesson title. But a quadrilateral, that means a four-sided figure, with parallel opposite sides is called a, you guessed it, parallelogram. A quadrilateral with parallel opposite sides is called a parallelogram. And here's an example of a parallelogram. Okay, remember this symbol means parallel. So see how these two segments each have one of those symbols on it? That means that AB is parallel to DC. And this side has two of those symbols. And this side also has two of those symbols. So it means that AD is parallel to BC. Okay, so again, two pairs of parallel sides. It has to be two pairs. Okay. Now, there are many key properties of parallelograms that you have to know. Okay. So let's start with these four. Opposite sides of a parallelogram are congruent. Okay. Oh, and by the way, you see it up here, but this is the symbol for parallelogram. So you don't have to write out parallelogram if you're ever referring to a parallelogram. I'm sick of saying parallelogram right now, but that's the symbol for it. Okay. So the opposite sides of a parallelogram are congruent. Okay. Also, the opposite angles in a parallelogram are congruent. Okay. So based on this diagram right here, since the opposite sides are congruent, it means that AB is congruent to CD, and it means that AD is congruent to BC. And since the opposite angles are congruent, it means that angle A is congruent to angle C, and it means that angle B is congruent to angle D. Also, the consecutive angles in a parallelogram are supplementary. So, A and B, those are consecutive angles. They add up to 180. The measure of angle A plus the measure of angle B equals 180. B and C are consecutive. So the measure of angle B plus the measure of angle C equals 180. Think of these as like same side interior angles. C and D are also consecutive. So it means the measure of angle C plus the measure of angle D equals 180. And then angle D and angle A are consecutive. So it means that the measure of angle D plus the measure of angle A equals 180. Okay. And this next theorem, if a parallelogram has one right angle, then it means it has to have four right angles. That should make sense based on the theorems above. Think about it like this. Let's pretend we know that G is 90, and we don't know anything else. So just pretend that we know that angle G is 90. So let's say we know angle G is a right angle. If G is a right angle, then it means J is also a right angle because the opposite angles are congruent. We just learned that above. And again, if G is 90, then it means H is 90 because these are consecutive angles and they have to add to 180 because they're supplementary. So if G is 90, H is 90. And by that same logic, if G is 90, K is 90 because these are also consecutive angles. So these are also supplementary. Okay? Now we're going to do a proof. We are going to prove one of the theorems on the previous page. Okay? So I said, let's prove that the opposite angles in a parallelogram are congruent. Let's prove that theorem. Let's prove that the opposite angles in a parallelogram are congruent. So I want you to prove that angle A is congruent to angle C, and I want you to prove that angle B is congruent to angle D. So my first statement, we're given, remember that symbol means parallelogram, we're given parallelogram ABCD. Reason one is given. 1 second. Okay. Since we know that we have a parallelogram, that means that AB is parallel to CD or DC, either one. And it means that AD, I'm just going to label a diagram, is parallel to BC. So that's going to be my second statement. I'll say AB is parallel to DC. And I'll say that AD is parallel to BC. Remember, this symbol means parallel. That is the definition of a parallelogram. Okay, I gave you that right here. A parallelogram is a quadrilateral with both pairs of opposite sides parallel. That's the definition of a parallelogram. Where are we going to go from here? You can use anything you want except the fact that the opposite angles are congruent, because that's what we're trying to prove. So you can use anything else you want. So here's what I'm going to say next. I'm going to say, and notice how I gave you a big space in this statement and reason. I'm going to say angle A and angle D. Those are supplementary because they're consecutive angles. So angle A and angle D are supplementary. Also notice that angle D and angle C are supplementary because they're also consecutive angles. Also notice that angle C and angle B are supplementary because they're consecutive angles. For that reason, I'm just going to use this one right here. The consecutive angles in the parallelogram are supplementary. I'll say consecutive angles in the parallelogram are supplementary. Okay. Now, let's focus on the first one. Angle A is congruent to angle C. Look at my first two statements of statement 3, okay? The first two parts of statement 3. If A and D are supplementary, and D and C are supplementary, that means angle A has to be congruent to angle C. Because they're both supplementary to angle D. Let's pretend angle D is 10 degrees. That means angle A has to be 170 because they have to add to 180. And again, if D is 10 degrees, it means angle C has to be 170 because they're supplementary. By that same logic, let's look at the bottom two parts of statement 3. If D and C are supplementary and C and B are supplementary, that means B and D have to be congruent to each other because they're both supplementary to angle C. So let's pretend angle C is 50 degrees. I'm just making that number up. That means D has to be 130 because they're supplementary. And it means B has to be 130 because they're supplementary. So they're both 130, so they're the same. There's a name for that. We did that in Unit 2, I believe. It's called the Congruent Supplements Theorem. The Congruent Supplements Theorem. Two angles supplementary to the same angle, or two congruent angles, are always going to be congruent. Two angles supplementary to the same angle are congruent. That's called the Congruent Supplements Theorem. Example 2. Quadrilateral LMNP is a parallelogram. Find D, the measure of angle PLM, and the measure of angle LMN. Let's start by trying to find D, okay? LM is congruent to PN because the opposite sides of a parallelogram are congruent. So since they're congruent, it means that they're equal. You don't have to write that out on a test or quiz. You can just go right to 2D equals 22, and D equals 11. Make sure you answer every part. That was find D. Now let's do the measure of angle PLM. Okay. Well, you should know that angle PLM is congruent to angle MNP because the opposite angles in a parallelogram are congruent. So it means that their measures are equal. So the measure of angle PLM has to equal the measure of angle MNP. So the measure of angle PLM has to equal this angle down here, which is 42 plus 66. So 108 degrees. The measure of angle PLM equals 108 degrees. And then don't miss any parts. Now let's find the measure of angle LMN. LMN and the angle we just got, PLM, those are consecutive angles, so it means they're supplementary, so it means they add up to 180. So I'm going to say the measure of angle PLM, the angle we just got, plus the measure of angle LMN, the angle we're looking for, has to equal 180 degrees because they are supplementary, because they're consecutive angles. So it means 108 plus the measure of angle LMN has to equal 180 degrees. So it means the measure of angle LMN equals 72 degrees. Okay, make sure you answer every part in the question. We just did. Okay. Another problem like that. Quadrilateral JKLM is a parallelogram. Find A, B, measure angle MJK, the measure angle JML, measure angle JKL, and the measure angle KJL. Oh my goodness. Okay, here we go. Let's start with let's start with the measure of A. We know that JM is congruent to KL because the opposite sides in the parallelogram are congruent. So it means that JM equals KL. Again, you don't have to write that down on test or quiz, but we know that 3A equals 21. So we know that A equals 7. Great, that's the first part. Check off each part so I don't forget any. Now let's find B. We know that JK is congruent to ML because the opposite sides in the parallelogram are congruent. So it means that JK equals ML. So 2B plus 3 equals 45. Two B equals 42. B equals 21. Let's find the measure of angle MJK. The measure of angle MJK, do that down here. Let me do one thing first. Okay, so the angle MJK is what we're looking for. We know that angle MJK is congruent to angle KLM because they're opposite angles. So it means that the measure of angle MJK equals the measure of angle KLM. So it equals 70 plus 30, which is 100. Next up top is the measure of angle JML. Okay. Well, the angle that we just got, the measure of angle MJK, we just got that angle, plus the measure of the angle we're looking for, JML. They have to add up to equal 180. Let me fix that really quick. Okay. So the measure of angle MJK, the angle we just got, plus the measure of angle JML, the angle we're looking for, has to equal 180 because they're consecutive angles. So I'm going to do 100 because we just got that, plus the measure of angle JML equals 180. So the measure of angle JML equals 80. Next, we need JKL. JKL is up there. That's congruent to JML. It's congruent to the angle we just got. So let me just write down what I'm doing. That way you see. Angle JKL is congruent to JML. That means that their measures are equal. So it means equals 80 degrees also. Check it off so I don't miss anything. Now we just need KJL. There's a couple ways you can think about this. Okay, a couple ways you can think about this. Since it's a parallelogram, this angle and this angle down there, those are going to be alternate interior angles. So they're going to be the same. So they're each going to be 30. Or if you look at this triangle on the top, this angle down there is 70. JKL we just got was 80. 70 plus 80 is 150, which means that has to be 30. Think about it like that. I'm just going to say that the measure of angle, not even that. Let me just put the angle symbol. I'm just going to say angle KJL is congruent to angle MLK because MLJ because they're alternate interior angles. Because remember, we're told it's a parallelogram. So that means that the measures are equal. So it equals 30 degrees. Okay. That was a long problem. It wasn't really hard per se, but it was just long. Okay, one more major theorem that you have to know. The diagonals of a parallelogram bisect each other. Okay, so this is the diagonal. RT is a diagonal and US is a diagonal. They bisect each other. So it means that RQ is congruent to QT. Mislabel that. It means that SQ is congruent to QU. Notice how the diagonals are not necessarily equal, okay? So it doesn't mean that US equals RT, okay? It means that this part is congruent to that part, and this part is congruent to that part. What are the coordinates of the intersection of the diagonals of parallelogram ABCD with the vertices A 25, B 66, C 40, and D 0, -1? This is like a good SAT kind of question. Let me just draw a parallelogram really quick. Now, when you name a parallelogram, it has to be in order. So, for example, if I say ABCD, I can't label that like A, C, B, D. I have to label in order, either clockwise or counterclockwise. So if I do A there, I'll say that's B. I'll say that's C. I'll say that's D. Let me draw the diagonals. Do that in blue. One diagonal. That's the other diagonal. Okay. You need to find the intersection of the diagonals. So I'll just label that dot right there. How can you find that point? One way to find it is to find, since you know this is congruent to that, and this is congruent to that, just find the midpoint of one of the segments. Okay? I'm going to say, let's find the midpoint of AC. So that formula is x1 plus x2 divided by 2, comma, y1 plus y2 divided by 2. Let's do it with AC. So 2 plus 4 divided by 2. Comma, 5 plus 0 divided by 2. It's going to give me 6 divided by 2, comma, 5 divided by 2. Let's make it 3 and then 2.5. I'll say the diagonal of the intersection of the diagonal is 3, 2.5. I'll say the diagonals intersect at 3, 2.5. Let's just double check our answer. Let's see if we get the same answer when we do the midpoint of BD. We should, right? BD. 6 plus 0 is 0. 6 plus 0 is 6. Divided by 2 equals 3. Perfect. 6 plus -1 is 5. Divided by 2 equals 2.5. Perfect. Okay, one more theorem today. Each diagonal of a parallelogram separates the parallelogram into two congruent triangles. That should make sense because if you think about it, the opposite sides of a parallelogram are congruent. So this side is congruent to that side. And then this side is congruent to that side. And this side is in common to both. So look, the two triangles are congruent by side, 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 side. Okay, we're going to finish this lesson off with a couple of practice SAT questions that I took off of sample SATs. These were each labeled with as hard for the difficulty level, for whatever that's worth. Okay, quadrilateral ABCD is a parallelogram. Find the value of Z. So here's how I'm going to do this one. This one's pretty tricky. We have to write a system of equations. So for these two angles, and again, there's more than one way to do this problem, but I'm going to say that 2x plus 3 plus y equals 180. Because we know that the consecutive angles are supplementary. And then I'm going to say that x plus y also equals 180. Let's clean these up. 2x plus y equals 177. X plus 2y equals 180. Now let's solve using either elimination or substitution like you would do in Algebra 1. Okay, so I will solve this one using elimination. I'm going to multiply the top equation by -2. Okay, I'm going to multiply everything in my top equation by -2 to get the following. I'll get negative 4x minus 2y multiplying the top equation by -2 equals 177 times -2, which is -354. I will leave the bottom equation alone. So that's just x plus 2y. Actually, I'm doing this one. I might be making this a little too hard. There's more than one way to do it, of course. But when I add these together, I get. Actually, there's a much easier way to do this. Let me do it. Let me do an easier way. This way is fine, but I want to do it an easier way. Hold on one second. Okay, so the way I was just doing it was perfectly fine, but I'm going to do it an easier way because this lesson's already long enough. Since y and z are the same, why don't I just eliminate the x's to make it faster? So I'm going to multiply the bottom equation by -2. Leave the top equation alone. 2x plus y equals 177. Let me multiply the bottom equation by -2 to get -2x minus 4y equals -360. I left the top equation alone, and I multiplied the bottom equation by -2. That way, when I add these together right now, the x's get eliminated, and I'm left with -3y equals 177 minus 360, which is -183. And that gives me y equals 61. Again, the reason why I claimed that was easier than the first way I was doing it is because I know in the original diagram that y equals z, because those are opposite angles, and in a parallelogram, the opposite angles are congruent. So if y equals 61, then it means that z equals 61 also, and therefore my answer is done. I don't need x. I don't need x. That's why I chose to eliminate the x. And get y, and then z is the same. So if y is 61, z is also 61, and that problem is done. Here we go, last example. I know it's a long lesson, okay? Shout out to you if you watched it all, okay? Quadrilateral ABCD is a parallelogram. Find the value of x times y. So let me write two equations again. I'm going to say x plus y equals 112, because those are opposite angles, and the opposite angles in the parallelogram are always congruent. And how about I say x minus y equals 42? Because these are alternate interior angles, and they are congruent. Now I can just add my two equations together to eliminate the y's. Let's add these together to eliminate the y's. And I get 2x equals 154. Because the y's get eliminated. And that gives me x equals 77 when I divide by 2. And now let's find y. Go back into either equation and solve for y. I'll go back into the top one. X plus y equals 112. And we just established that x is 77. Y equals 35. Now remember, the final question said find the value of x, y. So let's go ahead and do that. xy equals 77 times 35. So 77 times 35 equals 2,695. And that's the final answer for that one. Again, these two questions that we just did, those are like questions I took off of sample SATs, and they both had a difficulty level of hard. Choices are easy, medium, or hard. And these two are labeled as hard questions, for whatever that's worth. But I know this lesson was long, but that is the end of it. Unit 7, Lesson 2, Parallelograms.